I've never.
Everything that you want for your graphing calculator is under the catalog. So if you don't know where to find it, the catalog is alphabetical.
I don't know what the catalog is.
Mine doesn't do that. The button that says catalog is.
I thought you were saying it's like an actual catalog.
No. There's a button right here. See it? It says catalog. So if you wanted absolute value and you weren't sure where it was, everything's under. It is in that. But if you didn't know where, everything's under the catalog alphabetically. So you go to the catalog, and if you want to go to D, you just hit that D where the alpha. The alpha. Hold on. Come on. There we go. So if you did the catalog and then you just chose a letter, it would skip to that part of the catalog also. Okay, but yesterday we graphed this and we didn't have enough time to talk about it, but this graph is the original function, and we have not reviewed how to graph x to the fourth minus 4x squared. We haven't gone over that. That's not one of our parent functions we get. So for you to know if the inverse is a function, you can actually use the regular function just as is. You can look at this, and if a horizontal line will cross through this graph more than once, that tells you that the inverse is not a function. That's all it tells you is if it's a function or not a function. This horizontal line, because once I take it and I reflect it in the y equals x line, then you would use a vertical line. But I don't know how to reflect this yet because I've never graphed this before. So if we graph it on our calculator and we look at it and we say, is the inverse a function, what would you tell me? No. You would tell me no, because a horizontal line passes through this graph more than once. So that's all that question was about. I think we talked about it, maybe not, but I think we talked about it, that when you do find the inverse, if it's a function, you would write like g of x equals, but if it's not a function, then you would just write y equals. If it's not a function, you would just write y equals instead of writing g of x equals. That's the only difference on that worksheet. If it's a function or not a function, that's the only difference, is that you would write either g of x or y. Yeah.
So what's the difference? I got confused between the horizontal and the vertical. I got that one.
Well, the vertical line test tells you if something's a function, okay? So that's kind of what the graph looks like on your calculator, on my calculator. Is this a function?
Yeah.
Right? No, you're right. Yeah.
Okay.
Yeah, it is.
Usually
Okay,
I'm wrong, so.
but is the inverse a function? Do we have the inverse? We don't have the inverse. So if my only question is the inverse a function, why would I even find the inverse if I don't have to? So I can find the inverse. The inverse is going to look like, it's going to look like this. Okay, that's what the inverse is going to look like. But, and then I would, if I know the inverse, I would use the vertical line test, and you could tell me, nope, the inverse is not a function. Okay, but then you have to find the inverse. So that, this whole horizontal thing would be, if you don't want to find the inverse, you could just check horizontally, because that's going to be the same thing as vertically once we flip it. Because when we do inverse, all the x's switch with all the y's. So instead of vertical, it would be horizontal. That's all that's about. And all we're going to use it for, again, all we're using it for is, do you write your inverse as g of x, or do you write your inverse as y equals? That's the only thing we're using it for. And I've given you at least one of each out of those 6 questions. So there will be at least one that is a function, and at least one that's not a function, if not more. On that worksheet that you're supposed to do, you know what I'm talking about?
Yeah. 6 questions.
The 6 questions. Don't worry, we're not grading it today. If you didn't do it, you can still work on it class today and ask the question. Okay. Let's go to, whoa, hey. Let's go to this question. Example 6. Let's go to example 6. We'll do example 6 and example 7 for the rest of the notes. We don't need to do every single example. So example 6 says you're going to verify algebraically. You're going to verify algebraically. You know what that means?
Yeah.
Kind of. It means you're going to show all of your steps on the paper to prove it. Remember doing things where you had to prove stuff? Well, kind of. So we're not writing words. But do you remember doing things where you had to prove stuff? You have to like show all your steps. We're just going to algebraically do it, so you just have to show all the math. You don't have to put the reason next to it. You just have to show all the math. What? Oh, okay. Well, we're not going to do that anyway, so. So what I'm going to do is I'm going to show you the steps, so you have 2 steps that you have to do to prove it. And I'll try to color code it so you can follow along. This one I'll make blue, 3x minus 1. And this one I'll make red, x plus 1 over 3. Step 1, you have to show that f of g of x is equal to x. Okay, remember that inverses undo each other, and they are symmetric in that y equals x line, that y equals x line. Right? They're symmetric in the y equals x line. So when they undo each other, they should equal x. When they undo each other, they should equal x. So what we do is we go f of g of x. What is g of x? So I'm going to do f of x plus 1 over 3. We do f of x plus 1 over 3. And what that means when I have f of something, that means in the f equation, wherever you see an x, we're going to make that a parenthesis, x plus 1 over 3. Wherever you see an x in the f equation, I'm replacing that x with what g is. I'm just taking one function and putting it inside the other function. Now, I do not have to do anything to the left side. That's just the directions that are saying f of g of x. I just have to do the stuff to the right side. I need to simplify it and see if it equals x or not. So this is now just arithmetic, algebra, stuff that you should be doing and sometimes make silly mistakes on, right? So this is the way I look at this one. This x plus 1 is one quantity. There's understood parentheses around the x plus 1 because you have to divide the whole thing by 3. After we divide the whole thing by 3, we are now multiplying by 3. So if I'm dividing by 3 and multiplying by 3, those are opposite operations. And what do they do to each other? They cancel. So I have x plus 1 and then minus 1. And then once I cancel out those 3's and I have x plus 1 minus 1, these parentheses are not needed because nothing's being multiplied anymore. So I can just drop those. And what is x plus 1 minus 1? X. So yay, that one works. Check. Oh, that's supposed to be green. Now for step 2, we're going to do that again, except this time we're going to start with g of x. We're going to do g of, and then inside we're going to do the f equation, 3x minus 1. So I'm going to take the g equation, which is x plus 1 over 3, and wherever I see an x, I'm going to replace it with 3x minus 1. So that's the first thing I'll have is 3x minus 1 plus 1 all over 3. So I took my g equation, I replaced the x with 3x minus 1. You don't do anything to the left side. We're just going to work on the right side to simplify. So on top, there's understood parentheses right here. It says do this first. I'm going to do 3x minus 1 plus 1. What's 3x minus 1 plus 1? 3x over 3. So x. Yay, I just proved it. They are inverses. And I proved it. Okay. So when I say verify, I'm looking for all this work. I'm not looking for you to just take the equation and find the inverse. I'm looking for you to show that they undo each other and equal x. So we got 2 more examples, same stuff. Let's do the next example. So we're going to show that f of g of x equals x. So I'm going to start with my f function and put g of x inside. So g is cube root 2x. Wherever I see an x in my f, I make that parenthesis my g. So 8 is not part of the x. Parenthesis, cube root 2x, close parenthesis, cubed. So I only replace the x with the parentheses for g inside. So I took out the x and put that in. Okay? And then we're going to think about order of operations. We need to cube before we multiply by 8. So we're going to cube a cube root. What's that do? So we get 8 multiplied by 2x. So 16x. Would that work? Okay, so here's where I start thinking, did I make a mistake or are these just not inverses? So we got a backup plan. Let's try the other one, because if the other one works and this one doesn't, probably something's wrong. Because neither of them should work if it's not an inverse. Let's just try the other one. Good practice. We'll do g of f of x is 8x cubed. So we're going to put that into the g. So I have a cube root 2 parenthesis 8x cubed. So wherever the x was, that became the 8x cubed. The 2 still out there. And we can simplify that. That's going to be the cube root of 16x cubed. And is 16 a perfect cube? No, 8 is. I could have cubed it up, cube rooted it up here. This would be the same thing as 2x cube root of 2. And that's definitely not equal to x. So we can conclude that these are not inverses. You can say that they're not inverses. Yeah. I mean, if one doesn't work, then neither of them should. But what if you made a silly mistake that you just can't see? Oh yeah, then just try the other one. Or miss points because you were too lazy to do the other one, you know? So I would suggest trying the other one, and if both don't work, then you're probably good. But I do see a lot of just silly mistakes, especially at the beginning of the year, when we haven't had it drilled into our head, what happens if you cancel over addition, you know, things like that. You guys know what happens if you cancel over addition? Yeah, like if you cancel those x's right there, do you know what happens?
That can't happen.
I know, it can't happen, but unfortunately it does happen, and then there's casualties.
Oh, that's so sad.
Exactly, so don't do it.
Because it's brutal.
So you don't do it?
So you don't do it. Because not everybody, and I know there's somebody in this room saying, why can't I do that right now?
Because they're full money.
Well, that's why I would suggest you don't do it, but mathematically you can't do it either. And we will go over that over and over and over that again and again and again. We will. But somebody's going to do it. And I'll call you out.
I've killed a lot of puppies.
Have you?
Yeah.
Poor thing. All right, one last one. I would like you to try this start it, and then we'll go over it together. I'll put the answer up in a moment, but I'd like you to start it on your own first, see that you understand what to do.
I was still using the FOG, like I'm still using the.
Yeah, I just didn't put the directions for the code.
So I'm Homer. Actually,
Right, so you gotta redo it. Like I said, don't do the back. Oh, that's only for transformation, so you don't need to.
Oh, okay. I just
but-
I used to use the key.
Right. Yeah, you won't need to do that. I mean, it doesn't hurt, you're just gonna have to put it back in, because you're just, these are simplifying, so factoring is kind of the opposite of simplifying. Because, when we plug in, wherever the X is, you can do this, it might help you a little bit more, like wherever the X I plug in, it's around it. So you go, well, how do we put this first? And then we'll take the negative.
Right. Yeah,
So we can't go in here. We'll get rid of that first.
I'm just wondering.
Okay, that's just proceeding. Oh, you added those, okay, so you can't do that yet, because, so this is multiplied by -1, and this is addition. What do we do first, multiply or addition? So you have a negative sign outside of this. I know, like, first. All right, I'm gonna put the work up. I'm gonna put up the work. So for the first one, f of x, we're gonna do f of g of x. So that's going to do f of that of x, cube root negative x plus 4 equals negative parenthesis cube root negative x plus 4 close parenthesis cubed plus 4. We're putting g inside of f, and then here's your order of operations stuff. You're going to have to cube the parentheses first, then after that multiply everything by -1. So I'm going to have negative, and I'm going to cube the parentheses, and the cube root cancels, so we have negative. I apologize that my board is deciding to do these extra dots today. I don't know why. I've switched the battery, so I don't know what's going on with it. But I'm going to do negative x plus 4, and the cube root and the cube cancel, plus 4. So that negative outside has to distribute in, and we get x minus 4 plus 4. So we get x, and then that one works. So you got to be aware of your order of operations, otherwise you're going to make mistakes on these. And then the other one, we're doing g of f of x. So we're going to put the f inside of the g. We'll have a big cube root, and I'll have a negative sign. Then I'm going to put my f in, which is negative x cubed plus 4 plus 4. So my first thing I'm going to do is distribute that negative sign. I'll have cube root x to the third minus 4 plus 4. And so we'll have cube root x to the third, so we'll have x. So these are inverses. All right? Okay, we have one last example, the last graph, and this last one's going to help you on some of those homework questions. This last one. Oops, I forgot. 1 second. So the last question is find the inverse of f of x equals square root x plus 2, and then we're going to graph the functions in the same coordinate plane. So I'm going to start by graphing square root of x plus 2. So I'm going to do that with parent functions and transformations. Do we know what the square root looks like? Okay, so that square root is going to be translated where? Up 2. So instead of at 0, 0, it'll be at 0, 2. Instead of at 1, 1, it'll be at 1, 3. So we're just translating each point up 2. And then I'll have my parent function. Not my parent, but my original function. And before I even find the inverse, let's just go ahead and graph the inverse. Remember how we graph the inverse without actually knowing the equation yet? Do you remember that? What do we do? What do we do? Switch the x with the y's. So here where I'm sitting at 0, 2, I'm now going to go to 2, 0. At 1, 3, it's going to be 3, 1. 4, 4 is still 4, 4. And 9, 5 is now 5, 9. And what can you tell me about this red graph? What shape is it? The red one? Well, square roots go this way. It's part of a parabola, right? Because what does square root? Squared. They're opposite. So this has got to have a squared in it when we're done, but also it's only part of it. It's not a whole parabola. So you have to include that. So let's do the algebra part. We've got f of x equals square root of x plus 2. So first thing we do is make f of x y. Then we change the x and the y, so I have x equals square root of y plus 2. And we subtract the 2. We have x minus 2 equals square root y. And then what cancels out square root y?
Square.
So we will square both sides. You square the whole side. And I'm going to leave it as x minus 2 quantity squared. Because that is a parabola with a transformation. If I were going to multiply it out, it would look like this. I'm not going to multiply it out. But if I were going to multiply it out, it would look like this. Because you'd have to write this twice and FOIL it. But that we haven't done much with. We did transformations, though, and this is a parabola with a transformation. What's the transformation on that parabola? Which way?
Right, too.
To the right, 2. And if we go over here, we look, isn't this look like part of a parabola that starts at 2? Yeah? So with our equation, we have to tell whoever's looking at our answer that this is only half of the parabola. We have to put a restriction on the domain. So it's going to involve x. Which x's are graphed? All of them? No. Which x's are graphed? Starting at 2 and then above. So greater than or equal to 2. So that you'd have to put that restriction on. And then there is one last thing. Is the inverse a function? If the inverse is a function, we write this in function notation. So we'll actually have g of x equals x minus 2 squared, comma, x is greater than or equal to 2. That would be our final answer.
That's why they have that on the side, is because it's part of something.
Because it's part of it. It's a piece. Remember we did piecewise? Will be on your test next week. Piecewise.
Putting it all together, it makes more sense.
Right. And the more we practice it, you'll understand it more. So the rest of class from now till lunch and after, We have a lot of time. We have a lot of time. So your job is to finish the 1-8 worksheet. And that review that I handed you, that is not over the entire test, it's just over transformations. And you guys have a lot of time.